Hello, SolarLune here. Hi, how's it going? I'm the creator of MasterPlan, which is an independently made graphical idea board, project planner kind of thing for game dev. And I'm going to be working on that on stream today. How's everyone doing in chat? But yeah, I'm the creator of this application. It's going pretty well. Last time we left off, I was trying to implement stacks, and the idea of a stack is basically you can easily drag, well, these are cards, and you can easily make a stack by dragging them into kind of the area surrounding them, and then they will automatically sort, and you can do stuff based off that. It's just it's just kind of a simpler method to sort stacks, to store stuff around. And so I've added this ability where if I press F1, I already had this debug view, but I added the ability to kind of see the stack that a card belongs to. So that's pretty useful because that way we can see basically if it's working correctly. And it seems like it kind of is, where you have two stacks, but then if you drag one card into another, now you have one stack rather, and you can see it expand horizontally as well, which is good. And that was useful because this wasn't working properly. It was only working if the card was like exactly here. If it was off by one, it wasn't creating a single stack. So that's this this visualization is helpful. So I think part of the problem, part of the thing that we were missing is, yeah, as you can see, it's not working correctly. And I think part of the reason why it's not working correctly when you drag multiple cards is it really needs to update the stack vertically from the top down for every card. And I think currently it's basically not doing that. So what we need to do is go to where are we at? Is it here? I think we need to probably do something like this specifically to have we need to loop through the cards vertically, so we need to sort it differently. But I think that's what's missing here. I think when we go to card, we can't set the stack directly after locking the position. We have to set the stack in an update stack function, which gets called because basically cards are sorted according to vertical, like, you know, they get raised if you click on them. So, you know, like this card's on top. If you click on this, now this card's on top. And so the update order is reversed compared to the draw order. But basically clicking on them changes where they are in the list. We don't really want that when we're talking about stacks because we need them to be executed or calculated vertically, going from the top down or the bottom up, but they just need to be consistent. I think that's part of the problem. So that's what we'll be... Oh, excuse me. That's what we'll be investigating, essentially. And we'll see how that goes. Should work pretty well, I think. Let me get some music going. And I think, hopefully, by the end of today, we'll have, like, a pretty solid outcome. In the chat, Malik Martin says, "Hi, SolarLune. Hello. Welcome to the chat. Welcome to the stream." Let's see if we can get some music going. That works pretty well. Hopefully it's not too loud. If it is, please let me know. Crunch this around a little bit. There we go. Okay. All right. So yeah, what we're gonna do, we're just gonna go to the card. We're going to do something like this. We're gonna go to the page and we're gonna say we want to sort the cards vertically. So vertically. Vertically. I guess actually we don't need to... Yeah, I guess this is fine. We can do it this way. Or you know what? Let's not make another... another function. We can just do it like that. So card.setStack. All right, we're good. Let's try that and see if it makes a little bit of a difference in when or if this works. All right, this is better. Or it's really the same, but all right, that's better. That's better. Yeah, that's better. Okay, so now that we have this kind of a situation where we can tell which stack a card is in. Dementia Dementia Precot says, hello, I just discovered MasterPlan and it's great, and I love it. Oh, thank you. Thank you very much. I'm glad to hear that people are using MasterPlan, and I think it definitely serves a purpose. I think it's a good tool. It's just a matter of improving it from my end, but I think that's very useful even now. I think that it's an extremely powerful tool for people who plan stuff out, who lack productivity, or just need some help in that regard, or just need some help kind of tying together different concepts. It's software kind of unlike other tools I've used, so in that regard it's kind of unique, and it seems to work pretty well, I think. So thank you very much. I'm glad people like it. And Malik says it's great. Got it on Steam, should have got it on itch. No worries. Yeah, either one's fine. If you got it on Steam, please feel free to leave a review. I'm at 35, I think, 36. So any other any other additional reviews can help push it over that little gap between being very positive and overwhelmingly positive, I think. Because I think the vast majority of reviews have been positive, which is great. I really do appreciate it, and I hope to continue working on it and to continue making it a good tool. But that's kind of interesting. We solved it basically. So in a sense, so you place cards, they get put into a stack. Now we can kind of just push through it, I think. I guess we can, because the stack of the cards have been, Malik says, for sure you got it. Thank you. I really do appreciate that. Thank you. And if anyone else wishes to try it out, please check or take a look at the description. My itch and Steam pages for MasterPlan are there. I also have a Patreon if you wish to support development. I really do appreciate it. Okay, so I think we don't have to call update on the stack. The stack manager can do that. We don't have to do this. Okay, so the stack manager calls update, which calls update order on the stack. It also removes stacks that are empty, and that's basically it. How does... Oh, this should be page dot status response debug view. So this was working, but only over multiple turns, like only over multiple frames. If we do it just once, then this doesn't work. Why doesn't it work? Doesn't really matter which size. I don't think that needs to be done. For card and range vertically, set stack. Get stack. Stack, add. Okay. If we can get this work, we should be good to go. So I have to think about this. So we're sorting it vertically. So this should be updating its stack or setting its stack, and then this should be setting its stack. This gets some new. So I'm trying to like walk it through. So when we drag multiple cards, the one on top gets a stack from the stack manager. There's no object, there's no other card or no other stack in this area, so the first stack on top creates a stack. Then the second one should be dropped into the same stack. So why isn't that working? Let's see, stop dragging. When we release, we lock the position, and then we put it on the grid and we update the stacks, which is here. So all that happens in update, and then we update the stacks here, and that's correct. Okay. So if page.update stacks vertically is this, we're sorting stacks vertically, or sorting the cards vertically. We're setting each card stack. Okay. Get stack for stack. Let me do this. Let's see. Why is it not in the same stack? It doesn't really matter which one, like which one goes first in this example. What matters is that they go one after the other. So if it's not a matter of timing, something else must be happening. Why would the stack manager return a different stack? I guess that's the question. Let's try this. Okay, let's try that. I think that should show us that it's... Nope. Which one is P? I believe it's P. TJK says, yo, yo, yo. Hello, TJK. Welcome to the stream. Okay, so they both have the same stack. You can see the pointer is the same. We move it, and now they have two different stacks. So this is kind of indicative of the problem. When we call get stack, it's giving us two different stacks, despite the fact that if we after setting the stack for one card, oh, we need to update the thing. That's what it is. We gotta do this. We gotta call update order. Yeah, okay. Got it. So what we will do this. We will take this out of here, and that might make a difference, or that should make the difference. I'm not sure if that will be the solution. That is the solution. Okay. Oh. How's this? How's this not the same stack? Card rearrange vertically, stack equals. Okay, we're getting the stack, we're updating the order, we're setting the bounds. It's like this, then it's like this, then it's like that. Cards is greater than 0. I guess we could just push that down there. Top is this one. Grid size, okay. Bottom right, one up, dragging. There we go. Okay, let's see. What if we don't do that? What if instead we have basically the previous locked position of the rectangle, and we work with that? I think this might be part of the problem. So we will do something like this: card.lock previous lock rect equals card.rect. So when we're dragging it, yeah, okay, all right. I think I'm on the right track. So now when we go back to the stack, we don't use card rect, but rather the previous locked rect. Basically what I'm doing is making it so that when you're dragging a card, like previously when you have a stack, right? So it's like A, B, and C. You take C, you start dragging it, it removes it from the stack. It should really actually remove it from the stack, shouldn't it? Well, I guess it doesn't really matter whether it's removing it from the stack just yet, but you have A, B, and C, right? A, B, C. You move C. how I handled this was when you move C, it would be like, okay, well, we're computing the size of the stack. When a card is dragging, it no longer contributes to the size of the stack. Instead, we will just contribute the previous position of the card when it's not being dragged, essentially. That should work. Geek Hunger says, hey, hello. Welcome to the stream, Geek Hunger. Welcome. And I believe that should be basically what we're missing. All right, so something like this. All right. Something like this should kind of get us closer. Yeah. So for those who are new to the stream, you know, who are not really who don't really know what's going on, I am working on the stack system for MasterPlan, so that basically when this works, you'll be able to just like drag a card into a stack and it will just automatically sort. Take a card out of a stack, it will automatically sort. Move a card into a stack and it will automatically sort, all that kind of good stuff. Okay, so we're getting there, So the issue here is that the card is still a part of the stack when we drop it. So basically we're sorting all the cards vertically. So the stack, we need to remove the stack remove the card from the stack when it starts being dragged, I guess, essentially. That seems wise enough. Something like this. Let's try that. Geek Hunger says, "Oh, you've got it going." Maybe it's kind of getting there. It's not quite there, but it's kind of getting there. This is the best solution so far. Let's see. After we update after we sort it, yeah, this should be as simple as just, well, after we update the order, we need to reposition the cards, and then we can get the bounds of the stack, I think. So we'll comment this out for now. And just say that the top left bounds are the top card, and the bottom bounds are the bottom card. Minus GS. Okay, so that should be bottom. Bottom X plus bottom width. Whoops, forgot to make this bigger for everyone who wants to see. Previous locked. Height. Let's see. x plus width, y plus height plus GS. Okay. So this should kind of get us there. Remove card from stack as soon as bounding boxes don't overlap anymore. Currently, we're not doing it. We're not doing this every frame because that would be wasteful. Instead, we're doing this when a card is dropped, as you can see. So that's better because that way we don't have to like run through all the cards on the page constantly. We only have to do it when you drop a card or move a card, and even that it might not be as performant as we would like, but we'll have to see. Bottom is, let's see. So we got top and bottom. So bottom, hold on. There's people doing stuff in my house. Let's see. Why is it? Let's see. So we got bottom, x plus bottom width, bottom y plus bottom h plus GS. That should be it. Let's try this. I want to see if top and bottom are ever the same sometimes. That seems like that might be part of the problem. So we remove the card when we pick it up. So we pick up the card, we remove it from the stack, we drop the card, we add it to the stack. Only check bounding boxes on drag and drop events only for the stack. Only the stack that the card currently belongs to. Yeah, that definitely seems wise. The problem kind of comes in because like the problem here, let's see. Get stack. We don't have to do it this way, actually. There's a couple of solutions or improvements we could work with. We don't have to have a previous locked rect because we already have the grid position of the card. So we can just take it like this. That, and then get stack is just going to be past card, and then contains because we already have grid extents. This would be after the overlaps. Other dot start. Let's see. Other dot start x is greater than selection and other gained x or other dot start y, other dot end y, and then we can delete these, and then we can go back and we can just say contains rect start card dot grid extents, or rather overlaps. Okay, that's better solution, I believe. So we can still use these. This still doesn't solve our problem. It's just kind of a simpler approach, I think. All right. So when we move it, because when we, okay, I see the problem. When we pick up the card, it's no longer in the stack, as to be expected. When we drop the card, it gets put in the stack. Like we put the card in the stack. But we update the stack. When we set the card in the stack, maybe we should call, because we're just gonna do this anyway. Let's do this here and do this here. Seems wise. Let's see. So we can't remove the card from the stack when dragging. We have to remove the card from the stack when it's released, I suppose. Let's see. Man, I'm like, it's kind of there. I stored the stack ID to the card, and stack has the bounding box values. When the card drops, check the corresponding stack with card ID equals card.stack ID and check if bounding boxes of card and stack overlap. It shouldn't be that complicated. It should be relatively simple. Let's see. Maybe we have. Well, there's not really a point in storing the ID specifically. We already are storing the reference to the stack. We don't need to check the ID, right? Like, fundamentally, this is a problem of basically when things are being updated. So let's go back. Let's not remove the card when we start dragging. Instead, let's just go back to what we have. Oops. Now it's not being updated at all. That's right. So before we wrap it, let's call it update bounds. Give it that. Okay, so this reveals there's a problem with our code. Apart from that, like the updating the bounds is incorrect. Yeah, we probably should do something like this. Left at X stack, and this is just what I did down here essentially. All right, so if rect, okay, bottom right, so this still could be bottom. All right, so something like that is kind of a mixture of both. Let's see. Okay, so at least it's correctly setting the bounds. It's just not taking it out of the stack. So how do we know it's no longer in the stack when it is too far? So maybe we need a function that says if it's in the within the bounds. Because currently we're assuming that a card that's added to a stack is always within the bounds. If it's not within the bounds, it should remove itself from the stack. That seems logical. So we're not doing that here. We're doing that in here. Or, yeah. In the stack manager, I guess. Update. Update bounds. Not here. Here. So we're getting the stack from the stack manager. Basically, which stack would I fit into? Like the stack, the bounds are correct on the Y. It has to be a little bit above and below so that a card that is placed within the bounds, you know, gets added to the stack, like so, or like that, either above or below. The problem here is that this is considered still in the stack, because the stack bounds expand horizontally, because they should, you know, in something like this, they should expand horizontally, or something like that, they should expand horizontally. But if it's something like this, they're no longer within the same stack. They're no longer within the same horizontal realm. Why not make horizontally the same margin? I don't know what you mean. You mean like why don't you make it so that they can't exceed as you do vertically? I mean I can do that. Doesn't really help. Like making it so that there's a horizontal space wouldn't really change anything. The problem isn't that there's a space. There's no space horizontally. The problem is after two cards are in the same stack, you can basically move them like this. Like they're no longer, they're separated now, as you can see right there. But they belong to the same stack because I moved it shortly enough. I moved it small enough in small enough steps that it hasn't broken the stack like that. So I'm thinking that if this is sorted vertically, then we might be able to basically say that the stack is broken. I mean, we can say the stack is broken if it's like this, if there's a space between cards from one card to the next. Basically, if the X of card 2 is greater than the X2 of card 1, yeah, and we just keep stepping down a stack, then it's like, okay, there's a break there. But what do? We remove that card from our stack? Or do we just set the bounds to be here? I guess we could just we could do this, because if we remove the card from our stack, like that's not the job of the stack, right? Let's see. Okay. The thing is, I don't want it to say, oh, there's a problem with the system, i.e. there's a space between cards, a horizontal space between cards in a stack to the point where they are no longer a stack, and then just remove the card from the stack. No, hey, that does work. We could do that. You know what? Let's try something. Let's try something a little different. So we're gonna say first that the stack is just the size of the first card. So it's just this. So x and y minus gs to x plus width and y plus h plus gs. So this squared. For each card from one out, so the next card out, we're going to basically say if the card, and I guess we'll need the index actually. If the card y is greater than, or I guess we could say next y should be top.rect.y plus top.rect.h. We say if the y is greater than next y, then we want to remove all cards from I. Yeah, and let's see. Something like this. Yeah, something like this, because the goal here and we can break. So or card.rect.x. Top.rect x plus top.rect.w next x. Okay, otherwise then we say if okay, something like this might be more so within the bounds of possibility. Okay, and then we say next y plus equal card dot h. All right, so this might be kind of what we're looking for. Bottom declare but not used. Let's take it out. All right, so something like this might work. All right, so we have two cards here. They have two stacks. We move this one here. It extends. That's good. We move it too far out. It's no longer part of the stack. Okay. So that's a good start. It really should be basically at this point. So if card, let's see, rect.x, square the next x, top rect.x plus top rect. Next y plus equal card.rect.h stack.bottom right plus equal something like this might work. X goes bounds right, minus 16. So after removing it from the stack, like we can't put it back in the stack. Why is that? After removing it from the stack, we can't put it back. Why? So it's getting the same stack, but it's not being added. Let's see. Oh. 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 Okay. And then we can say card stack equals no. All right, that's part of it. Okay. This is better. I think it's going to be better. So if we get too far, it gets removed. If we put it back, now it's part of it again. We're not worrying about it horizontally to the left because this is an invalid stack ordering, because it's basically going to be like 1, 2, you know, like this 1, 2, 3, you know, like that. 1, 2, 2.1, 3, or A, B, B, A, B dot A, C, something like that. So having something that's too far left of the first X isn't really that big of a deal. We're not going to worry about that too much. About this being an invalid stack, like, you know, that's, you should kind of be able to see it looks weird. But this is good. This seems to be working. Of course it doesn't work when we drag all of them. We're so close, dude. Let's see. So what's going on when we drag all of them? The first card establishes a stack in its new location. Following that, we do update bounds. Okay. So at least it's indicative of a problem here. Let's see. So the first stack is, wait. Okay, so the first stack was empty, then the second stack does exist with the first card in it. So that's correct. But now when we move it over here, the same thing is happening. I'm thinking it must be removing the card. When it updates the bounds, it must remove the card from the stack because... But that doesn't even matter, right? This is hard, or, you know, it's difficult because essentially we have to update the bounds both frequently and infrequently. Like, we have to update them when you, for example, drag two cards. The first card needs to exist, or the second card, doesn't matter which, it just has to be consistent. The first card gets dropped and it updates the bounds. It updates the bounds of the stack. The second card knows that, basically says which stack should I be in, and it says this stack because you're in the bounds, right? Cool. But the problem comes in because when we do this, I think what's happening is we're placing the first card. No, that couldn't possibly. Let me see. Let's try this. It was removed. Doesn't really it doesn't really matter which was removed. We're just trying to see, is that being called? Okay, that is not being called. So it being in two different stacks is something else. So it's not due to this. So it must be just getting the wrong stack. I guess just, is it that it doesn't overlap? we put the card in the new grid position before we do anything with stacks. So we know that the cards are in the right position. And it's always returning the right stack. The first card returns basically a new stack. The second card returns the first card stack. We can see that their first card is there. Oops. Yeah, we can see, no, this is the first card stack. This is also the first card stack, but for some reason it's not using that first card stack. Why would it not be using the first card stack? It's setting the stack. It removes it from, I guess if stack card is second to nil and stack is equal to, you know what? Why am I even doing it this way? Well, let's see if card has stack is not going to stack. Yeah, okay, this is the same. So we're switching from one stack to another, and if the other one exists, then we're removing it from the original. We're setting it. Okay, and then we're adding it to the next one. Is my debug drawing broken, or are they really in the same stack? I'm pretty sure it's broke. The debug drawing is working because it's just drawing the balance of each stack in the stack manager. So there's two stacks here, one around each card. You know what? Let's do something else. What we're gonna do, we're gonna try debugging this a little bit. I want to go to here. I wish to let's see. Because this, let's see, the bounds are updated. We're sorting the card slice vertically. Like I'm right there. Alright, so what I'm going to try is updating to see what if I can see the contents of the card stack. Or I'm sorry, the contents of all of the stacks. So I guess it would be the contents of the stack manager. So that would be probably like here. Would be a good place to go. Waiting for the debugger to start. There's a breakpoint. I believe it's running. I believe it's debugging, starting up the debugger. In the meantime, I will look at other songs. That's so loud. I guess we'll go with this. Maybe it's not running? Okay, let's try this again. Uh, okay, so it is there. I'm not sure why it's not actually debugging. Normally, it takes a little bit on like first startup, but it doesn't usually take like that long. While it's debugging, we can keep mentally debugging. All right, so the problem isn't in the placement, although that is kind of a problem. I think this card thinks it's still part of this stack. Like its stack is, I don't think its stack exists. Let's change the debug drawing so that it uses a different color instead of white, so we can see it a little better. Can we use give me like yellow. Yeah, there's no debug here. There's no debug, there's no stack here. So it removed this from its own stack, which is okay, but then this doesn't have its own stack following that. So I guess what we need to do is, let's do it this way, because this is the cheapest way possible mentally for me to understand this or deal with this. We're gonna just like spam it. So basically if page.updateStacks runs, then we set it to be false, and then we run through and basically update the stacks for each card. In update, we will call update bounds. In update bounds, we go ahead and update the bounds of the stack. Now, if the debugger finally started, but I think we don't really need it anymore. At this point, we say, okay, we're gonna go ahead and if in this kind of a situation, we're gonna go ahead and remove cards that are outside of the stack from the stack, and then we're gonna go ahead and say stack.manager page update stacks to be true. So basically, if it doesn't work out on the first frame, then we're just gonna give it another frame. So that's not a perfect solution, but at the very least, this allows us to kind of shift the opportunity of being mind flooded from us to the computer. Yeah. Incredibly, that doesn't solve the problem. How is this? How? I don't understand. How is this? This has its own. Okay, well that's not necessary. This has its own stack. Why does this have its own stack? It's probably a simple problem. I'm not sure. Eboat right. Hello, welcome to the stream. How's it going? I'm being destroyed. I'm being mentally bodied. Okay, so the current problem for anyone who's just joining the stream is we're making a stack system, which is working. It should look like this. But when we drag multiple cards, sometimes it looks like this, where each card has its own stack. They should not have their own stack. They should share a stack, because they are together. So as you can see, it's making multiple stacks. It should just be one square, like this, or like that. Well, wait. Yeah, like that. So we have to figure out why this is happening. Now it's not. Now it's working correctly. That's weird. Why is it working correctly now? Okay, well, maybe we could do this another way. how would we define stability? If we can just iterate on updating the stacks until stability is reached, then it doesn't really matter if it's accurate or not, because it doesn't have to work in one frame, it can work over multiple frames. And the problem is, like, I would like to simply be like, okay, why don't we just do it like this? Wait. Wait a second, hold on. That's how it works currently. Okay. I'm like, am I misunderstanding? No, that's the way it works currently. Yeah, so this, I guess this is just the problem we need to solve. So it's creating multiple stacks when we don't need it to. So let's do this. Now that the debugger's up and running, we will go to, I think we'll create a breakpoint here in Stack Manager update once we have something like this. Okay. Okay. Then we move it here. Okay, so now Stack Manager update is called. And we can take a look and see we have two stacks here, and each one has one card in it. Okay. So it is genuinely two different stacks. Okay, so let's take a look here. It may be because it's not being removed. We already know it's not being removed. It must be simply getting a different stack. Is that what the problem is? Give me pointer stack. Okay. I know I did this previously, but I have to take another look at this. Okay, so these are indeed two stacks. Why? Hold on. So we're calling set stack. We're removing this card from the stack. We're adding the card to the stack. We're updating the bounds afterward. Whoops. We're updating the bounds afterward. It's not I think it's just not adding the, like, these are two different stacks. This is the same stack. This stack has one object in it. This stack has the same stack with two objects in it, two cards. We move it. This stack has no objects in it. That's this is the stack before we put the card in, and then this is the stack after we put the card in. I don't... You know what, let's do this, hold on. Let's do this, because I want to divorce any possibility of, like... I want to take out any possibility of something weird going on. So, something else unexpected. Alright, so boom. So we loop through each card vertically, we get its stack, we set its stack. By setting the stack, we should resize the bounds of the stack, and we're doing it from the top down. So this should be set, and then afterward, this should be like, okay, I'm in your bounds. So when we're printing out the card vertically, the stack of each card vertically, we have two different stacks, right? Okay, yeah, we have two different stacks. This one and this one. They both have one card in them. The bounds are 160, 96, to 448, 192. Okay, and we're gonna do a couple other things. It would be nice to debug draw the position of the cards so we can kind of get some visual information. Yeah, so we will draw card, draw contents, draw post draw. That we can just do it in draw contents. Globals.text render.draw. Render text. Should be something like this. And I'd like to put in card.rect.x, card.rect.y. Can I transform these to ints? Text. Left. All right, that should help us out, I think. Oh, nope. Let's see. If you create a new stack, you should check that no other stack has this card. That should not be necessary, because if we are already looping through to ensure that no stack could contain this card, then like either okay, I think I see what's going on. So when we loop through to get the stack, the issue is that it's basically let's say we have two. We can actually visualize it. So you have a card, right? You got another card. Oh, that's how it works. So you have two cards. You got this card, you got that card. They have two stacks, the yellow boxes. You put them here like this. There's one stack. When we move the cards, I think what's happening is that we're creating, I'm not sure if this is correct, but I think we're creating possibly this, maybe this card hits first and therefore gets its stack first, so it creates its stack first. So this stack is here, then this card is created and this stack is here. But when we loop through, no, wait. The theory that I'm kind of wondering is, it's possible that when this card is looking for a stack and this card has already been placed down, it sees its own stack rather than the stack of its neighbor. And basically the problem is because when we place a card down, it gets a stack if it exists, and if it doesn't exist, it creates a stack. We need to store those stacks, so we store those stacks in the stack manager. When a card is placed down, it also sees, is there a stack that I could fit in? But the problem is that it's going to loop through and it could find its own stack before it finds any other stacks, any neighbors that have their own stacks. So the kind of the problem is when we loop through to get a stack from the stack manager, it should loop through the stacks in order of vertical positioning. So this stack should be first, this stack should be second, so that when this stack goes to see, is there a stack I can fit in, it doesn't check its own stack first. It checks the stack above it, the stack vertically above it. That might work. That might be the problem. So let's go ahead and do this. We're going to sort the stacks. Sort.slice rather. Stack manager stacks by basically stack manager stacks misspelled it bounds top left y is less than stack manager stacks j bounds top left y return. All right, that might do it. That did not do it. Let's see. Let's fix this debug draw. Let's see. So we just do it like this. Oh, it's supposed to be D, I think. All right, that should help us out a little bit. Yeah, better. Can we kick it over by like, I don't know, let's kick it over by like 128 maybe? A little bit more. Lucretius says SolarLune. Hello, welcome to the streams. Lucretius, I almost said SolarLune. How's it going? We're embroiled in a problem that has had no solution for a while, or at least it hasn't been solved for a while. So this is the first stack, this is the second stack, right? 416, negative 224 to negative 128, negative 128. And then secondly, we have negative 384, negative 192. Yeah, so this is the first one, this is the second one. So sorting the stack didn't help. You still on the stacking cards thing? Yeah. Dementia Paracox has to go. Sorry. Or rather, thank you for stopping by. It's been enjoyable streaming on this problem. It can't be that hard. It's not. It's one of those things that's like, it's not that hard until you start programming it and you just run into like problem after problem. We can't just remove. If you want to make it easy, when dragging cards, remove them immediately from all stacks when dropped, run the solver. We can't do that. We tried that. I tried that earlier. What we could do is maybe remove all cards. Like remove all cards when you drop. Like basically recalculate all stacks all of the time rather than recalculating the stacks of just the ones that are moving. That might be the better approach, but let's see if we can get this working. I feel like we're not too far off. 32. Okay, so this one is definitely running first, so let's go back. Whoops. let's do it like this. Give me card ID as well as the stack. You can 100% brute force this problem without any lag. I would like to be able to. Okay. Hold on, I need to do that. Alright, so we have 0, we have 1. So 0 and 1. So they both point to the same stack, but if we move them, they point to different stacks. This one and this one. This one has... What? Okay, yeah, these are two different. You're right. Okay, so 0 has a stack that has, I'm assuming, its card, and then 1 has a stack that is its card. So how are they getting two different stacks when they they must let me just do this. You need to design the stack as part of the model of the program instead of as a feature. You'll have to be a little bit more specific. I'm not sure what you mean. This is weird. It's creating one new stack when we drag it, as it should. That should be the 0 stack, and then 1 should be added to that stack. You could also have a final loop that merges overlapping stacks. That way we don't care how many copies the cards create. That's a... I mean, like, if we're going to do that, why even have this stacking manager? That might be just a simpler approach, is to basically just merge the bounding boxes of nearby cards, but that's basically what I'm doing. Like, that's what I was kind of doing when we started, was basically trying to be like, which card is next to me? You know, let me define a stack for it. Like, if we're gonna have a stack manager and stacks and all this, you know, cruff, it seems like we might be better off just being like, there's a box around each card. Let's just see if the boxes overlap. And that's kind of just it. Islam says, "Hey, SolarLune, how did you customize your GNOME desktop?" I didn't really do too much. This is Manjaro with Blur My Shell, and that's about it. I don't. This is a Plank dock, but otherwise, there's not really any other like customization on the desktop. So it's creating a new stack, which is fine. Let's try that. Create a new stack for card 0. Create a new stack for card 1. Create a new stack for card 0. So where is card 1 getting its stack from? If 1 isn't creating its own stack, where is it coming from? Okay. So I'm thinking what's happening is when we drag it, let's say we drag it like this, right? So they're both in the same stack. When we move this over, 0 creates its own stack, but 1 is still a part of the previous stack. Okay, that must be what it is. So removing the card from the stack when dragging might be necessary. Okay, let's try that. Instead of a list, use a nary tree. Your model's a nary tree-like structure. I don't know how you're storing your cards in code, but it feels like a list of cards with position info. Instead of a list, use a nary tree that is calculated based on card position every time a card is moved. I'm not sure what a nary tree is, but I'm using, let's see, nary tree. Inary tree. Tree allows us to have any number of children of a particular node. I don't quite see how or why this would be applicable to my particular problem. I mean, if this is what you're describing, because what you have here is yeah, slightly more complex than a very common binary tree that allows us to have as most 2 children of a particular node. I mean, what I have is basically, ideally, just a single list, like a single vertical list. There's no need for a binary tree or even multiple children in a binary-like tree. It's just a single line. Yeah, but I think the core problem with this design is that the second card belongs to the old stack. When we pick up the card, they basically should be removed from the stack, I guess. So card.stack, I guess card.stack is not to nil. Card.stack.remove card. Let's try that. Your stacks are exactly that, children. No, you have children and also subchildren. There's only a stack is just a list. It's just a single 1, 2, 3, 4. There's no subchildren. Why again do you even need the stacks? I ask myself that every day. All right, we're better. It may not be perfect, but it's better. Good Lord, man. Why is this too different? How is this too different? Like, just like jacked up. Jacked up stacks. All right, I have to go back to the drawing board. What do the tabs do? The indents, they indicate like whether a card, like you have. I had this working, but it was like 1. This would be 1.1. This would be 1.1.1. This would be 1.2, 2, 2.1, 2.2, 2.3. So the indenting and stack system. The stack system allows us to tell if a card is indented. Well, you can tell if a card is indented already, but essentially, the stack system is useful because if you drag a card into a stack, it could rearrange the stack to fit. So if you have a stack like this, let's say you have a stack of 1, 2, 3, and then you have another card. This is A. If you drag it here, it should now be 1A, 2, 3, like that. It should automatically push everything below A down to make room for A. And then if you move A out of the way, it should move everything below where A was up. Yeah, the stack system that I have isn't working, so I have to figure out another way to do it. I think the easiest way to do this might be, because I really, if we already know that we're doing this in vertical order, I think that was the missing part of how I was doing this previously. I think if we just maybe I'll just go back to the previous way I was doing it. Because the card, like the stack system is a cool idea, but I feel like it might be an complication of the core problem. Like you just want to basically say, for this, start at the top card. It doesn't really matter which card we're talking about. And then loop down through the cards. Well, yeah, start at the top card, get your next card down, and set that information up of like, I'm the top, you're second, you're third, you're fourth, or just put it, add it to the stack. We don't really need a manager. We just need whichever card on top to know what it is. Physics joints? No, that's way overcomplicated. The reason I suggested it is because it'd be easier to do this if you had a data structure for it. Inserting would be trivial with iterate. I mean, that's fine, but the problem, I don't really want to like redesign the entire program, of course, to work with stacks. Stacks are they're a feature of the program. They're not, I don't feel the need to overcomplicate the design. The design works fine. It's simply this feature that's the problem. If the right way to do it is to redesign the program, then I can't do it the right way. It's just, I have no interest in rewriting the program again so that the cards are structured differently. I think that's unnecessary, given that, and especially if they're not really structured in an iterate visual format. Like, they're structured kind of freely, and a stack in this application is just a single vertical list. There's no tree. They're just a vertical list. No need to redesign, just insert the cards into a tree structure inside the stack manager. Less with the sorting logic and more with the update timing. Okay, here's what I'm gonna do. Here's my concept. So step 1, we're gonna loop through all cards that have been dropped. We're going to find the top cards. We're going to, these are the heads of the stack. Loop through all children, add them to the stack. Done. That's basically it. That's my new strategy. Well, I guess this would be, let's do it like this. I guess the first thing would be to sort cards vertically. So that's the idea, is we sort the cards vertically. We loop through all the cards that have been dropped this frame, so that we don't have to loop through every card on the plan. We just have to loop through the ones that are moving, loop through the ones... Wait. So if you have a card, you move it here, for example. We can't loop through all the cards that have been... We can't find the top card here. Well, I guess we can find the top card. This might work. All the cards that have been dropped this frame, find the top cards. So basically, in this example, it would find this card. So you place it here, it basically just looks up one, finds that card, finds its stack, it adds itself to that stack. You move it away, this has been dropped, this is the top card of its own stack. Loop through all the children, add them to the stack. All children of... So I guess there's two possibilities. This might work. This might be this is basically how I was doing it originally, but I feel like this might work. Seems ambiguous in some cases. What you show by adding items to the head of the stack, which causes two stacks to form rather than a single one to update, is really not complicated, but I get the desire to do something you're familiar with. Yeah, I don't know about iterate trees, and in order for me to implement that, I would have to basically look it up and implement it on my own time, which I don't mind, programming on my own time. That's what I do, but I'm not familiar with it. So for me to do this with that idea, I'd have to basically have done it before. If I don't know that it could be applied to this application, I could look up iterate trees, spend days, looking it up and either finding a library to do it ideally quickly, or spending days implementing my own, implementation of an iterate tree, apply it to this program, to this problem in MasterPlan, and it not work, and have to go back to the drawing board repeatedly. And I am not against going back to the drawing board or spending time on something, as you can see. But it's different to spend time on a problem with an approach that you think could work, and spending time on a problem with an approach that you have no idea could work. Your suggestion is great, but I haven't personally experienced it, so I don't really know anything about using an in-array tree for this application, for this kind of a thing. I'm not familiar with partitioning techniques. I gotta work on that. But until then, I just don't feel comfortable. Let me take a look at it again. Okay, the in-array tree is a tree that allows us to have n number of children in a particular node, say, hence the name in-array, making it slightly more complex than the very common binary trees that allow us to have at most 2 children in a particular node. Pictorial representation is as below. In the in-array tree shown above, we can notice that there are 11 nodes in total, and some nodes have 3 children and some only have 1. Yeah. In the case of a binary tree, it is easier to store these. Store these children nodes as we assign 2 nodes left and right to a particular node to mark as children, but here it's not that simple. I don't quite see how this applies. Again, like how does this help? How does this solve the problem? You actually don't need it for this problem. You were right. I misunderstood. Okay. All right. I'm cracked. In case you can't tell, my mind is pudding. It's mush. All right, that's okay. Thank you for the suggestion. Maybe I still need to look, get better with partitioning schemes. I'm not familiar at all with binary trees, in-array trees, KD trees, any of that. I don't know. I've never implemented or used them. I really should, because I know that they are useful in data representation, or I guess data storage more specifically, or more correctly. Yeah, that's okay. Aren't we all just a little bit cracked? I think we are. I think it's just about how cracked are you. The more you realize how cracked you are, the better a human being you become. The more you realize your mental acuity is dropping, the stronger the rest of the acuity that you have remains. Somebody put that on their Instagram bio. Okay, so what we're gonna do, we're gonna apply this. We're gonna do this as naively and as simply as possible and just solve the problems that rise up. If we sort the cards vertically, I guess we'll just do it like this. So basically, when you drop a card, it will add it to a list of cards that have been dropped this frame. At the end of the period, at the end of the update, it will loop through all the cards that have been dropped this frame, sort them vertically, find the top cards, these are the heads, and then just progressively push down until it finds the... That's a better solution. When looping, rather than looking... wait. Yeah, we don't have to do this because this is after update. Okay, so this should be good. This should actually work. So we're not gonna have a stack manager. I don't feel like we need a stack manager anymore. All right, we'll keep a stack manager. I don't know. Do we need a stack manager? I feel like that might be overly complicated. A stack is a sequence of cards. We don't need bounds anymore because it's only be purely based on neighboring, like it was. Let's try. Yeah, we'll keep a stack manager, but we will rewrite this entire thing. Okay. So the way this is gonna work, we have a stack, which is a struct. It's a sequence of cards. Whoops. Okay, well, I'll have to delete this file afterward. It's a sequence of cards. We have a stack manager. Now, a stack manager doesn't actually store the stacks. So maybe we don't even need the stack manager. Let's keep moving. So a stack is going to be something like this. Okay. Keep the stack manager. This is high level code. To high level code in pure binary, then convert the binary to genetic code. A, B, E, 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 C, then boom. Stack manager has an important job. Okay. It does help in this particular problem, but you don't need it. And I can explain how, but much better to do things the way you know. It does help in this particular problem, after all. Okay. Alright, here's what we're gonna do. I'm gonna box this off so we know where we left off. Okay. So we're not losing anything. We're not losing anything. Not really. Not too much. Okay. So the idea here, a stack is just a sequence of cards. Simple. A card does not add itself to a stack. The stack manager adds the card to the stack after the cards have been updated and placed in their final positions at the end of the update frame. At the end of the update function. Okay. So, the stack manager contains not the stacks, I suppose, but rather get reset and start over. Maybe I should. The stack manager stores basically which cards need to be, which are we'll say moved cards, right? This is a list of moved cards. Okay, return stack manager. Alright, so the idea here is that basically the stack manager loops through each card in its moved cards, and then afterward it resets it. So what we want to do is basically say if a card is moved, we want to see if there's a card above it, and if not, it is the owner of a new stack, or it is the head of a new stack. If there is a card above it, then it will add itself to that stack, and that's basically it. We will sort the moved cards vertically. Okay. And then we want to basically find neighbors. Okay, so this is a good start. Add or get stack. Stack manager dot move cards equals a pinned card Okay, something like that. We will do something like this. Card. Okay, we'll do something like this. If length stack manager dot move cards greater than 0. Something like that. Why do you keep writing unnecessary constructors for structs? There's no such thing. I don't know what you mean. Like, firstly, I don't know what you mean. In case you don't know, like, this is a, like, okay. Firstly, it's always good to have a constructor rather than constructing a struct manually, because if you change the struct, then you have to change all the places where you construct the struct, right? Like, if I make a stack in Stack Manager, and let's say in 1 or 2 functions, and then I change the contents of the stack, now I might have to go ahead and change, you know, how that struct is constructed. Secondly, this isn't an unnecessary constructor because I'm initializing a slice. If you don't do this, then the slice would be nil, and you wouldn't be able to add anything to the stack cards slice. This new stack is unnecessary because since you are keeping the nil values, you aren't initializing or allocating anything. I'm initializing a new slice right here and right here. Without this, stack.cards is nil. Now it's with this, it's not nil. It's an empty slice. Okay, so this should be a good start. So now the idea is, when we lock position, we don't set stack anymore. We don't handle that. When we lock position, we say card.page.stackManager.getStack card. We don't handle update stacks anymore. That's the stack manager's job. So we say update stacks. We don't have that. Update stacks. We don't do this anymore. We just say page.stackManager.update. Go is complicated. It's not that complicated. It's pretty simple, actually. We'll just do that. I don't think we need the page. We'll see if we do need the page. All right, so this should be a good start. Okay. All right, so this should be a good start. So basically, we create a. We're just doing things as simply as possible. When we create a card, or when we move a card, or when we delete a card, it is running this code. Now, you should only do this for the moved cards. Ziotic says hello. Hello, welcome to the stream. You're watching a man mentally decompose in real time. Brain to lettuce, just like that. So what we're doing here, we're going to print out the card ID. I guess it doesn't even matter what we print. So this is working. The point is it's working. So now what we need to do, or no, wait, that's why I wanted to try. Okay, so we're going to print out the card ID. So we have 0, 1, 2. Now we move 2, we move 1, we move 0, we move 0 and 1, 1, 0. Okay, so this is working. This is working. So now where will we put the stack? Are we going to put it on the card, or are we going to put it on the manager? We could put it on the card. Really, this is just a neighbor system, right? So every card should have access to the stack, either through the manager or through the card itself. So that the card can query and be like, am I above, am I below? That's kind of important, right? For cards to know. especially because we draw their numbering. The numbering is here. If card.numerable, add drawable. Okay. Stack. Okay. Drawable. Draw number. Draw post draw. Oh, this is page. Whoops. Card.drawable. Okay. Did I? Okay, I did remove this. Okay, draw. All right, here we go. This is where the code is. That basically says, you know, let's draw like a little number next to the card. So this is, you know, 1. This becomes 2. This becomes 3. Or this becomes 1. This becomes 1.1. This becomes 1.2. So that's that. So what we're basically making here is a neighbor system as well. So let's do that first, because that's conceptually easier to grasp. So, and because they're kind of the same thing, I believe. So each card can have neighbors. It's easiest to get a neighbor if we, like a vertical neighbor in the stack. It's easier to get a neighbor if we have a dedicated object for it, a stack. Multiple cards can be in a stack. The stack should be shared between cards. Because, I mean, the alternative is that we basically put the stack, like a map of cards to stacks in the stack manager, but that would make it so that it's relatively slow when we actually go to get the neighbor. Like, if you want to get the stack for a card, you'd have to go through the manager map, which is going to be relatively slow the more cards we have on file. So it's easier to store the stack directly on the card. We have to store the stack directly on the card. There's no other way to do it, I don't think. Not performative. We have to store it directly on the card, I think. Okay. But the card doesn't handle putting it in the stack. The stack manager handles that. Okay. This is like the 10th time I've written this specific function. Range stack.cards if C is equal to card, and stack.cards I is append cards okay. All right. Geek Hunger says, if you store stack on the card, then cards don't share state, which may be complicated to deal with later on. Yeah, I understand and agree. That's kind of what I ran into the first time, but we can't put it anywhere else. If we put it on the stack manager, then we're maintaining a sequence of stacks, you know, a map. Either we have a map of stacks, of cards to stacks, so it's like, okay, you know, card A, B, and C belong to one stack, which could be slow when traversing the map if you have a lot of cards, right? Or we do it basically via physical location, which is kind of what we did before, and it didn't really work out because of the timing aspect of things and trying to like condense the bounding boxes. We didn't try condensing the bounding boxes, but I feel like it's easier to simply be like, the card above you is the stack that you belong to. Like, just look at the card above you. Get his stack. That's your stack. I feel like there's certain times where I feel like I'm on like the cusp of like understanding something or remembering something or figuring something out, and I'm having that mental feeling in my brain right now. Like I'm right there. It's just a matter of like mentally walking it through a little bit more. But let's keep going. Let's keep going. So I think this is a better design because we don't have to do it by the card. The cards don't have to do it, and we can sort them vertically, which is important. And we only are sorting the moved cards, not every card. That way we don't have to do like a whole bunch of stuff. So we basically say, okay, maybe we should just maybe we should just have each. Do we just? You know what? Maybe I'm actually overcomplicating this. Maybe what this is doing is just going to give us the neighbors. And then from that point, a card stack function would just basically say, if you're on top, return your stack. If you're not on top, return the guy above you stack. Because the guy above you is just going to say, well, if I'm not on top, return the guy above me stack. And if that guy is on top, he will return his stack. That might work. I want performance. Yeah, I want performance. I feel like at some point with this approach, we need to know neighbors. We need to have neighbors, vertical and vertical neighbors. And if we simply can calculate those neighbors. Hold on. All right, so let's say we calculate everything so the cards know what is above them, what is below them. After that, if we drag a card into a stack, it would get the card it's on, see what stack it's in, add itself to that stack, rearrange the stack. All right, I think that might be it, because we need to know what the neighbors are. There's no reason to have the card call out to something else to know what its neighbors are. Each card needs its own neighbors. Okay. And the neighbors should not be calculated constantly, because they only change when a card is moving. So let's do this. Above. Card below. Yes. Not neighbor. What's stack update? Update stack. Okay. So this is going to be update stack. This is going to be update neighbors. All right. So now we say above is card dot stack. Oh, that's why I needed the page. Okay. Cards indirect. Okay, so I just want to make sure that this is working correctly first. Okay. Cool. All right, now we're gonna say basically for above range. Grid size. All right, so this should kind of give us something to work with. So this sets up neighbors so that we all the cards know which is above them, which is below them. Now that's important because when it gets to the stack, that's going to be necessary. So this one is above this one is below this one. Okay. That's yeah, what it should know that. Let's actually test that, I guess. Nil, then card above ID is equal to card above ID. What? Oh, in 64. Okay. All right. All right, something like this. All right, hold on. Card below ID. Card below is not nil. Card below ID. Card below. All right, let's kick this over to the left a little bit more for visibility. And then also, right. card below, card above. Okay, let's see. Oh, okay. Below is -1. Why is below -1? Above is 1. Above is 0. Okay, so this is 0, this is 1. So that's working. But for some reason below is... Oh, wait. Oh, this is, yeah, we need to do something like that. You gotta be careful about working with pointers. I didn't solve it. Okay, let's see. Below is 0. Below is... Let's do a couple things here. Hold on. All right. X, Y. Let's see. Okay, so this is easier to see. So above is working. But below isn't. Let's see. So we go back to stack manager, card below, rect equals card.right, rect.y plus equal to height. Seems like it should be working. Cards in red. Next, continue. What's next? We can break out after that. Let's see. Card. H. Oh. This should be... This isn't the problem, but... that would help a little bit. H equals global grid size. Well, that we already said that. Oh no, we're equating it. That's right. Let's see. Pardon me. Let's see. Okay, so we're seeing a problem here. So it looks like it is working. It's just if you move this one, above is set, but this one isn't set until you move it. So the way to solve that is to, I guess we have to recalculate all of the cards then. We can't just recalculate the moved cards. Because you could move a card into position. Is there another way to do that? No, because the card could be of varying width, we can't presume On anything. Okay, so we have to work on all of the cards. We can't just work on the moved cards. All right. Manager, pages, cards, pinned, card, cards. All right, so we're all right. So this is I think better. There we go. So let's restart this. Hold on, so we can kind of see this better. So this is 0. This is 1. Above this one is 0. Below this one is 1. Below this one is 0. Above this one is 1. Okay, we're good. We're Gucci. This is working. This is working. All right. Now, the next thing we're gonna do, and this really isn't so much of a stack manager. It's really just a neighbor updater. And actually, that's pretty true. Yeah, we really could just stick this in page or something. All right, so this is good. So we're looping through. All right, we're loop through all cards. We can't do this anymore. We sort vertically. We find the top cards. These are the heads of the stack. Loop through all children and add them to the stack. Okay. So when we go back to Stack Manager, what we want to do, I guess we could actually keep a track of the heads. And then just inform them that they're the head. We can just give them the stack, because that's crazy, dude. This isn't even that hard. Because we're already doing this, we can already tell which cards are the heads because they have nothing above them. So basically, if at the end of this you don't have a card above you, then you're the head of a stack. New stack. We say if card.card above is equal to nil, then we give you a new stack. Otherwise, card.stack equals card. Yeah. All right. This is gonna be something like this. Hold on. Hold on. Okay, so I think what we're gonna do here, there we go. So we're gonna say this is like, I don't know, card stack, something like this. Whereas this is draw card. Okay, post draw. Is that it? Is it in there? No. Okay. Serialize. Okay. We're gonna put something here. We're gonna say card stack. It's going to return a stack, and we're going to say basically if card.card above is not equal to nil, then we return card.card above.stack. Otherwise, we return card stack. Okay. And then when we go to stack, we set the card stack. Yeah. I want to simplify this. I don't want to have this function on the card because I want to remove the possibility. I guess that's fine. Oh, we don't have to do that. We can just say if card.card above is equal to nil, we set card stack to be this. Otherwise, it should be nil. Okay. All right. So now that should make it so that they all basically, they don't share a stack, but if you call card.stack, it will give you the top, the stack object. Okay. But how do we add cards to the stack? I guess we could just call this actually. It's nil and then card stack add card. Okay, so I think this kind of gets us there. Let's see, if it's working, then we want to be able to do something like this. Yeah, we want to be able to do something like this. All right. So that should tell us basically, are we first? Are we second? We should be able to know that kind of information. And let's say we are doing this in the card itself. So we're drawing, drawing information. And then we just basically want to say, like, we want to be able to say something like this. Print line card.stack.index card. So tell me where I am in my stack. It crashed. It crashed because there's no stack. That's right. But that's necessary. I mean, that's kind of just something that needs to happen because it's possible that the stack hasn't been initialized yet. If card.stack is not equal to nil, then we go with this. Okay. I think that's fine. All right. So it's like, and give me the ID also. All right, so if this is working correctly, we should be able to basically just kind of freely arrange stuff. So this is... So 3 is now 0. 2 is 2. 2 is the third. 2 is now the first. 1 is second. 1 is now the first. 0 is the first. 0 is the first. 0 is now last. Yeah. So now 1 is first, 0 is second, 2 is third, 3 is fourth, 3 is third, 2 is fourth. Okay, so this is working. This is working. We move it, nothing changes. Everything perfect, beautiful. Okay. All right. So we're getting somewhere. We're getting somewhere. All right. Now next, what we want to be able to do, we want to be able to reposition them as necessary, but before we even get there, I want to see about reinstituting the numbering system, which is this. And that basically says if card.stack, we want to do it like that. If card. Well. There we go. All right, so if the stack is not equal to nil, then the numerable cards basically, and that's where I had any function cards if trunk false. Expected operand. Oh, whoops. There we go. Any undefined stack. Cards, knowledge memory, and either selected stack. Start above. Now I'm kind of wondering why do we even need a stack? I guess I guess index is kind of useful. I mean, because we could just put them directly on the card. Put these functions directly on the card. I guess there's use for this. All right. What am I looking for here? Bottom. Stack that cards. All right, so then we got card that stack all cards. Okay, if card.numerable stack that top. Gotta re-implement that. Okay. Stack, not stack that numerous. I guess it would be if not stack. And we want to stack numerous. Go to card and return numbers. Head. Okay, so this would be head card. All right. We should be pretty close now. This would be up or the head. So 02 stack.cards. Index card. Yeah. All right, so that should get us pretty close to where what we're trying to do. Let's go. All right, so that's more or less what we're trying to re-implement. So that's working. That's good. So we have the numbering system back. Moving the card should not, change the numbering, which is good. Whoops. A minor issue, but that's fine. We move it. Now this is part of its own stack. Move it back. Now it's part of the original stack. So that's working really well. We can always show that numbering. There we go. It's not perfect, but that's good. Now, if this is working, the whole point of the reason why we did this is that if this is working correctly, when we drag, for example, this one in here, it should move all of the rest out, and that's kind of what the stack system is made for. So we'll do that next. TJK says, I might have missed this, but how did you get text rendering to work? I'm not sure if you mean like just in general, but there's two methods of rendering text that I have implemented. One is to simply render it to the screen. The other is to render it to an image, a texture, and then draw that to the screen. Rendering it to the texture is better if it's in general. Okay, rendering it to the texture is better if you have some amount of text that's not too much, so that it breaks the limit of how big a texture can be on your graphics card, which my render currently that can happen, and so I need to figure out how I can resolve that, maybe with multiple textures. But basically, you want to render your text to an image and then draw that image to the screen if you have a lot of text, because otherwise drawing each individual glyph is going to be slow, right? Because you're drawing like, A, B, C, D, E, F, G, H, I. Rather than that, you can say A, B, C, D, E, F, G, H, I on some sort of off-screen buffer, and then just draw it to the screen one time. So the text renderer, you can take a look at the code on GitHub. I go through it, but essentially, and apologies if there's stuff going on in the background, but essentially I have a glyph that represents basically an image of a rune or an image of a Unicode character, I suppose you could say. That's not quite correct, I don't think, actually, now that I think about it. UTF-8, maybe a UTF-8 character, but basically a glyph corresponds to a texture of a drawing of the character. So like A or B or the capital letter A, those are glyphs. And so their textures, I do something a little fancy because I need the text to look a little better, because it's pretty heavy on, you're going to be looking at text a lot in MasterPlan. So the way I do it is I use render UTF-8 shaded. That's basically the SDLTTF library, rendering out a single glyph. I draw it on a black background with, I draw it on a black background with white text. Once that's done, I then take the pixels, and that's to a surface. Once that's done, I take the pixels from the surface and basically transfer it to another surface, but modifying the color, because basically when you draw something with render UTF-8 shaded, it's anti-aliased, so it's like black with white text, and the corners of the edges of the text goes basically gray. So that's good. But when you go ahead and try to transform it to be transparent, it's going to be either all like the black is going to be transparent and the gray will be full transparency. Essentially, that's what the problem is. Either it's going to be like white text on a black background, which obviously doesn't work if you don't have a black background, or it's going to be transparent, but the edges are going to be kind of jank. It's going to be a little crispy. Actually, we can demonstrate this by doing this, I believe. Yeah. So now if we go back and run this and look at the text, well, it's just black, colored text on a black background. But if we go with instead render UTF-8 solid, it'll look kind of crunchy. We can demonstrate this like so. See how it's like, it's really pixely? That's not good. The alternative would be render UTF-8 shaded or blended. Blended is going to be rendering at high quality, but if we look at how this dithers, yeah, it looks a little bad. Looks a little blurry, I think. So what I did is basically render it at UTF-8 shaded, and then we go ahead and it looks literally the same. Oh my gosh, I wasted so much time. I don't know why I did this in comparison with render UTF-8 blended. I don't remember. I have to look at it. But basically I guess that's not really that important. You render the text out, the individual letters out to glyphs. You store that in some sort of data structure, which in my case is a text renderer. It's a map of runes to their glyphs. And then when we go to render the text, we render it to an image. Usually that's the fast way to do it. We render it to oh, purple alpaca coding says hello, hi, welcome to the stream. But yeah, we render the text out to an image, and so we basically just step through the text we want to render, glyph by glyph, letter by letter, and then we wrap on new line characters, and also wrap if we exceed the word wrap max width. So if we set a width of 128 pixels, then when we exceed that, it will wrap back around. It's kind of complicated, but it works pretty well. And then the alternative is to just render directly to the screen, which is useful if you don't want to have to maintain an image, which we don't, not all the time. But yeah, this is working. This is working. The bottom line, this is working. It's working pretty well. Now, yeah, I'm tired and I'm hungry, and I have other things to do. But we will do one more thing. We'll try to do one more thing and make it so that if we drag... wait. Are we printing here? No, where are we printing something out? It's here? Okay. We will do one more thing. Oh, TJK says, thank you for the explanation. Awesome stuff. Thank you. Another question, how do you handle cards on screen versus off screen? Do you process and draw all cards, or do you use culling to limit how much you process? I don't do anything yet, but I believe the right way to approach it is to cull, visually cull the cards that are off screen, but process all of them all of the time. Because you might have timers on another map, on another page that go off. You might have deadlines or something like that. So because of that, every card needs to process, but only the cards that are visible need to draw. So that is just, rectangles. Just, rectangle for the screen, see if the card's in that rectangle, and if so, don't draw it. We don't have to draw it. Okay, so this should be working. So yeah, the next test is to be able to do something like that, and then have the rest of the stuff pushed down. So that's not too hard. Sounds like it'd be tough to process if you got an insanely large project. Yeah, that's true. So it would be kind of up to... It'd be kind of up to the user to do something about that. To basically be like, well, you know, I need to break it up into multiple pages. Like if your page is just massive, then you gotta do something about it. I don't know. You gotta approach that. I can see about optimizing, you know, on my side, but I can't optimize everything. I can't optimize infinitely. At some point, it's diminishing returns to the point where it's like, yeah, you just have to make another page. You just have to do something about it. Okay. So this is working. This isn't super efficient, but it's working. But what we need to do now is basically say if we drag a card onto a stack, which is, I believe, working here. I believe this is working correctly. Then we want to rearrange the stack according to vertical position of each card. That's basically it. I'm like blanking, but I think we're actually like basically done. We're almost done, yeah, I think. We'll make a map, which is essentially a set of slices, or not slices, of stacks that we've created. Stacks that each card has, basically. Yeah, I'm not even sure why we have stacks, now that I'm thinking about it. I can optimize it later. For now, this works fine. So this, we'll say created stacks, or I guess we'll just say stacks, is going to be something like this. It'll be a map of stack, something like that. And then we just say created or stacks, new stack. Or maybe I could just say it, because the card can only have one stack. I'll just say stacks card.stack equals true. And then we just loop through each stack, and we call stack.reorder and stack.reposition, I guess. Well, we'll just call stack.reorder, that's fine. Then up here in stack, we got the number, that's fine. We'll put it here. And we should be roughly there. Reorder. Stack.cards. We want to sort it by stack.cards i.rect.y is less than stack.cards j.rect.y. All right, and then we start at the head. Okay. And then we say for C in range, stack.cards from the first one out. C.y equals start y. Hold on. Stack.top.h c dot or start y plus equals c.rect.h, and I think that might be it. I'm not sure if it's working. 0, 1, 2. It's not working. Let me think. So it's adding. Is reordering? Is it reordering? Let me see. Hold on. I feel like I'm so close, dude. I'm so close. It is reordering. Okay, so it is moving. It's just. How's it sorting in this? Let's see. iCard.id. before and after. Okay. All right, so we got 0, 1, 2, and 3. So now you put this here. Now it's 3, 0, 1, 2. You put this here. Now it's oh, before. Oh. Wait. 3. 4. Yeah, 3 is becoming its own. It's taking its own thing. Okay, let's see. Hold on. Okay, what we're gonna do? Wrong position. What we're gonna do? We're gonna try. I don't like to do this. Let's try this. Hold on. I really don't like to do this. I feel like this isn't really where we should put this. Alright, so the problem here is when we drop a card, for example, there, we want to take 1's place. If we drop it here, we want to take 2's place. If we drop it here, we want to take 0's place. So we have to get the card in the position we're in and add ourselves to that stack ahead of the one that's there. That's not really a problem. But then we'll have to reorder it. I guess it's not a problem. Let's try it. So for other in range, okay, if other is equal to card, we continue. Otherwise, we say if other.stack is not equal to nil, other.stack.add card well, we could just say add card, and then we could try something like that. Let's see, we could try something like that. So you're adding it, then you reorder it. Okay, let's try something like that. Let's see how that works. It's not working. Let's see. For other in range, Reorder. Oh, we're not actually, hold on. I forgot we took out the code that makes it actually move. Let's see if this works. It might work. How did I manage that? Let's see. Oh, head would be the, okay. All right, this is close. This is very close. It's very close, dude. Pros. This is so close. This is exactly, I think, what I had like a couple of days ago, though. Oh man, I'm super close. I'm super close. But I can't keep working on this. I have to go. I got things to do. But I'm getting close. I'm getting closer and closer. I think this is. Actually, it would probably be like something better, like plus. That would help out a little bit. But yeah, I'm getting closer and closer. It's getting better and better. It's just a matter of like. It's so close, man. I'm like, I can almost taste it. Let's see, how would this work? So you move C down here. Reorder. Let's try this again. Hold on. I want to see something. Okay, so it's before 0, 1, 2, 3, and 4. Move this down. Before 0, 1, 2, 3. After. So before becomes its own. Like that works fine. Except for the freeze. I'm so close. Alright, I gotta figure this out. Thank you very much for watching. I've been SolarLune. It's been fun. It's been fun. It's been fun being on stream and programming. I hope to get this resolved and to yeah, I hope to get this resolved and to keep cranking stuff out. Thank you very much for watching. It's been real. If you want to support development, please feel free to check out the links in the description, my Patreon, this program, MasterPlan, which is on itch and Steam. And I'll see you guys on the next stream. See ya.